In lesson 7.1, we're going to look at understanding factors. The goal is to understand factors, and I want you to be able to find the factors of a whole number. Now, we've worked a lot with factoring tables, and we've learned and practiced multiple times that factoring is arranging. When we factorize a number, or when we factor that number, we take one number, we unmultiply it, and we end up with two numbers. Each of those numbers is called a factor. And the factors of a particular number let us know different ways that that amount could be arranged. I know, that's a lot of words. So let's take a look at this example. What are all the different ways they can organize the carpet squares into a rectangular array? So 4th graders at Ames School have 24 carpet squares. They have 24 carpet squares. What are all the different ways they can arrange the carpet squares into a rectangular array? So I'm going to create a factoring table for 24. That means I'm going to take 24, I'm going to unmultiply 24, and I'm going to wind up with two numbers. Where will I start? Well, I'm going to start with 1 times 24. This gives me one arrangement for 24 carpet squares. Is it even? Yes, 24 is an even number. It is 2 times 12. Is 3 on the list? 2 plus 4 is 6, so 6 is a multiple of 3. So yes, 3 is on the list. It is 3 times 8. Is 4 on the list? Yes, because 2 is multiplied by an even number here. So it's going to be 4 times 6. Is 5 on the list? No, because 24 does not end in a 0 or a 5. Is 6 on the list? Yes, because 2 and 3 are on the list. However, that factor pair will be 6 and 4. I already have 4 and 6. And so that's how I know that I'm done. So when I'm looking at the factorizations for 24, I could arrange 24 items, in this case carpet squares, in 1, 2, 3, 4 different ways. I'll show them to you now. The first factorization would be one row or one column of 24. Likewise, I could also do, I have one column of 24, I could do one row of 24. And so I could arrange those 24 tiles, those 24 carpet squares, in one column of 24 or one row of 24. And that would account for my 1 and 24. I could also arrange them in two rows of 12. So here I have two columns with 12 in each column. So that would be 2 rows of 12. I could also do 12 rows of 2. I'll show you those now. Or 12 rows of 2. 12 columns of 2. I don't know why I keep switching those words. I could also do 3 rows of 8 or 8 rows of 3. This color is a little lighter, and so I moved the camera so that you can see that here I have 8 columns of 3 rows, and here I have 3 columns of 8 rows. Those are factorizations that represent 3 and 8 as factors of 24. And the last one would be for the factorization of 4 and 6, which I can show you now. And so here I have 4 columns with 6 in each column, and here I have 6 columns with 4 in each column, and both represent the factorization of 24 as 4 and 6. And so factoring is arranging. Please remember that. Factoring is arranging. The first semester we had a project where we factored numbers and graphing. We got in groups and we factored numbers on some graphing paper. And so this is just a nice little callback and a nice little review of that concept. Factors The noun definition of factors are numbers that are able to be multiplied to make a particular product. So 1 and 24 are numbers that are able to be multiplied to make 24. 2 and 12 are numbers that are able to be multiplied to make 24. 3 and 8 are numbers that are able to be multiplied to make 24. And 4 and 6 are numbers that are able to be multiplied to make 24. And so numbers that are able to be multiplied to make a particular product are called factors. And that would be the noun definition of factor. Now, because we've done this so many times in the past, we will not be using grids to find all the possible arrays for each numbers. We'll simply create a factoring chart, okay? We'll create a factor chart. So for 6, all the numbers that can be multiplied to make 6. Where do I start? 1 and 6. 1 times 6. Is it even? Yes. So it's 2 times 3. Is 3 on the list? Yes. 3 is a multiple of 6, and so that will be 3 times 2. When my factors begin to repeat, I am done. With 16, where do I start? 1 times 16. Is it even? Yes. 2 times 8. Is 3 on the list? No, because 1 plus 6 is 7. 7 is not a multiple of 3. Is 4 on the list? Yes, because 2 is being multiplied by an even number. So it's going to be 4 times 4. When I get to a square number, I'm done. So for each of these, you will not use grids. You will create a factoring chart. As well as here, you will create a factoring chart. We have 5, 8, and we have 23. Here you'll create a factoring chart for 25, 36, and 27. Where do I start? 1 times 27. Is it even? No, it's not. Is 3 on the list? 2 plus 7 is 9, so yes, 3 times 9. Is 5 on the list? No. Is 7 on the list? No. Is 9 on the list? Yes, it will be 9 times 3, so I'm done. For 36, where do I start? 1 times 36. Is it even? Yes. 2 times 18. Is 3 on the list? 3 plus 6 is 9. 9 is a multiple of 3, so yes. 3 is on the list. It will be 3 times 12. Is 4 on the list? Yes. 4 times 9. Is 5 on the list? No. Is 6 on the list? Yes, it will be 6 times 6. And when I get to an even number, I'm done. And I'll just keep going just like that until I have a factoring chart for every number on the page.